So now we're getting into the derivative of sine and cosine, but I do just want to take a quick second to point out that there's more complicated stuff you could do for the power rule. So like for example, that's actually just a power rule problem. Something like this, that's actually just a power rule problem. So just be careful and realize that power rule works for other things too. So let's go ahead and do these problems. So first off, there's just a little knowledge we have to know. We have to know what the derivative of sine is and what the derivative of cosine is. So let's start with the derivative of sine. So if y equals the sine of x, then the derivative, y prime, is the cosine of x. But then if we have cosine, the derivative of cosine, I'll rewrite that over here. If y equals cosine of x, the derivative is negative sine of x. So those are two things you just have to know. I suppose we could probably find them with the limit definition. Maybe we'll do that as well. But we just really need to know these. And one thing that is interesting is look how it's going to cycle. So like if we did the second derivative, we took the derivative again of cosine. Well, we just said it's negative sine of x. But then if we take the derivative again, well, the derivative of sine is cosine. So the derivative of negative sine is negative cosine. But then if we take the derivative again, the derivative of cosine is negative sine. So the derivative of negative cosine is negative sine, which is positive sine. I'll write that negative sine, which is positive sine. So see how it cycles every 4. Kind of like I to the first, I to the second, I to the third, I to the fourth, and then it cycles. So pretty neat. And then we really just need to memorize that. So like here, the derivative of sine is cosine. So the derivative of 2 sine, y prime, is 2 cosine. And then B, kind of annoyed they rewrote it for us because we should know that sine of x over 2 is 1/2 times sine of x. So we do that anyway. Y prime is 1/2 cosine of x. And like I said with the last problem, it's nicer to write it how it started. So let's rewrite that as cosine of x over 2. Okay, beautiful. Now C, again, kind of like we talked about with the last problem, if we got functions added together, we just take the derivative of each one. So the derivative of x is 1. Why? Because this is just 1 times x to the 1. So when we bring the 1 to the front, 1 times 1 is still 1. X to the 0 is also 1. So the derivative of x is just 1. And the derivative of cosine is negative sine. So the derivative of this, y prime, is 1 minus sine of x. And so you really do just have to know those. You have to know that, and you have to know that. So should we try to do that with the limit definition? That's going to be tough, but we can probably try. So let's try to find if y equals sine of x. Let's try to do the limit definition. So we're going to do the limit as h approaches 0 of sine of x plus h minus sine of x over h. And I know this can get pretty challenging, but let's try it out. So one thing you should know from pre-calc is the sum of angle formulas. So if we have sine of x plus h, we can rewrite that. I have a song, so it goes sine, sine, cosine, cosine, sine. So we'll do sine, sine, cosine, cosine, sine. So I guess I did just talk about how you shouldn't memorize things like that. But some things I think you just have to. So I have a song for that. Sine, sine, cosine, cosine, sine, cosine, 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 sine, sine. And that does both of them. That does the sum of cosine formula as well. So anyway, now we have this. So the point of this is... What is the point of this? That's a good question. Well, I'm looking at this. Now keep in mind, I don't really know what to do here. But I see that there's a sine of x in both of these. So I'm going to write this so that it's proper first. And then I'm going to go and I'm going to try to rewrite this and factor out the sine of x. So we'll have sine of x on this first part, and then cosine of h minus 1, because that's minus sine of x, but we factored it out. And let's see, I really just want to separate these. So we'll have that fraction, and then we'll have this fraction. And then what can we do from here? That probably was brilliant, but we're not done yet. We still got to finish it up because we still can't plug in h equals 0. Except this part we can do right here, actually. This part, because... okay. I see. So another thing, we went over this, that you just have to know, is that the limit well, normally it's x, as x approaches 0, of sine of x over x is 1. You should know that. So this part right here, realize if we have the limits of things added together, you just take the limit of each of them. So we should know that from the last chapter. So my Apple Pencil just died. Can you believe that? We're not even going to edit this out. We're just going to sit in here for a second. Plus, you'll get to appreciate how quickly the Apple Pencil charges. Because see, we just plugged it in, and now we're going to unplug it. Oh, we'll wait a little bit more. Because what, we got 15 more minutes it needs to last? That will absolutely last the 15 more minutes. Alright, so now we plug in the iPad again. And it'll take a second to turn on, but it'll be there. And while we wait, I'll go ahead and rewrite what we had just said. That we're going to take the limit as each of these separately. So we're going to take the limit of that one separately. And we're going to rewrite it to see that we have this. So when we take that limit as h approaches 0, like the real issue here is that part. But we just said that that part equals 1. So when we take that limit, that's just going to become 1. That's going to be cosine of x times 1. That's just going to be cosine of x. And then we're actually going to do a very similar thing over here, because that's another limit that we need to know. That if we have, so we have the sine of x times cosine of h minus 1 over h. And similarly to this limit, we have to know that the limit as x approaches 0 of cosine of x minus 1 over x is equal to 0. So look at what's happening there. We're ending up with sine of x times 0, which is why that just goes away, and the derivative is just cosine of x. That's beautiful. I'm not sure I've ever done that before all the way out by myself, to be honest. Should we do cosine too? I feel like we're here. We might as well do cosine. We're going to need another page for that, though. Because it'll basically be the exact same thing. We'll use the sum of angle formulas. So... oh, wow. And is this just going to be negative because it's negative in the sum of angle formulas? That's going to be interesting. So what do we have? The cosine of x plus h minus the cosine of x over h. So just like before, we're going to use the sum of angle formulas. So the limit as h approaches 0 of the cosine one. So it goes sine, sine, cosine, cosine, sine, cosine, 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 minus... that's the trick there. Sine, sine. Beautiful. Minus cosine of x. All of that over h. And then we're just going to do the exact same thing we did last time. So we're going to rearrange them, but then we're going to factor out the cosine this time. So again, it's the first and the last term. So we have the cosine of x that we factor out. So we're going to be left with the cosine of h minus 1, because remember, just like before, that's right here, but we're factoring out the cosine of x. Beautiful. And see, that's like exactly what we got there, except there was sine of x times that. Very interesting. And then what do we have over here? Minus sine of x, sine of h. And yes, see how that was plus last time because this was a plus. But now in the sum of cosine formula, that's a minus. And so that's why that's going to be a minus. And again, just like before, we're going to separate that into the two separate fractions, over h and over h. So again, just like before, sine of h over h, that's 1. So this last part just remains negative sine of x. And cosine of h minus h over h, of course, when h approaches 0, that's just 0. So all we're left with is the negative sine of x. So that's really beautiful because it's one thing to have somebody tell you or plug it into your calculator to find just what the derivative of sine of x is, but it's a whole nother thing to start from your like fundamental definition of what's a derivative and really work it out. And it's really nice to at least do that for yourself once. Obviously, you don't do that for yourself every time, but doing it for the first time to see what it is, that's awesome.